Okay, this is kind of a silly question, just gives us a chance to talk about a couple different issues. The beam to be placed in the historic rehab is a 20-foot long W16 by 50. If each worker can carry 100 pounds, how many workers would it take to carefully move it into place? So there's a couple of things that you need to know. If I have a W16 by 50, the 16 is the nominal height. So it's not the actual height. It's not exactly 16 inches, but it's fairly close to 16 inches. So it's the nominal height. And then the 50 is the pounds per linear foot. And from the exam standpoint, almost always when we're talking about pounds, what we're really talking about is dollars. That if I have a beam that can work as a W16 by 50, but then I find another beam that also still meets all the loading capacities that I need, and it's a W16 by 48, or it's even a W18 by 48, it would be lower pounds per linear foot, and we buy steel by the pound, and so therefore it's lower money. So almost always when we talk about that last number there, we're actually talking about money. In this case, we're not talking about money, we're just talking about how heavy the thing is. So I've got a 20-foot one, it's 50 pounds per linear foot. So clearly that's 100 pounds times 10, so that's 1,000 pounds. We got 100 pounds per person, so that's going to take 10 workers to move. So the answer to that is going to be 10. As you start thinking this thing through, you sort of clearly realize, well, 10 workers carrying a 20-foot long beam, that's a little complicated, that's a lot of people. But this is actually the kind of thing that has to be thought through when you're talking about adaptive reuse or historic rehabs, where I can't always get the cranes in place, or I can't always use the sort of typical ways that you would be carrying these things around. I've got to maybe get something through a window and then up the stairs and then go through. I actually just had a situation like this where we had to calculate exactly how, whether we could get the beam that we wanted on the diagonal up through the stair and into the place. And it's a very embarrassing and horrible thing when you haven't done that and they're standing there with the beam and there's no way for it to get there and everybody's looking at you. It's not always your job, it may be the contractor's job, but it would be a conversation between the two of you and trying to figure out what's the sort of most reasonable way to answer the issues at hand. Couple kind of sort of quick issues here. If I have that wide flange, that W shape, that's a little thin there for the flange, but so I got the two flanges and then the web in between. The way these things are made, right, is that I have a series of rollers that I start with a chunk of steel and it goes through a first roller and it kind of gets sort of roughly shaped, and then it gets with another roller when these things are really hot, and all right, now it's getting kind of close. So it's going through hundreds of these rollers, and it gets closer and closer and closer, and eventually I get it to the shape I want, right? So this shape is that very efficient, really all the extras have been taken out. And the reason I mention this is that let's say instead of it being a W16 by 50, 50 is, for 16 is relatively light, it's not a super heavy beam. Let's say instead of that it was 110, so it was W16 by 110. Well then almost all of that weight would be added up on top here and down on the bottom, because it's the same set of rollers that are creating that steel. Now at some point they'll go to a new set of rollers, and so there's a couple of breaking points, but the reason I mention this is when it's the W16 by 50, that 16 nominal dimension is probably pretty darn close to the actual dimension. But at the 16 by 110, that's a much chunkier piece of steel, so that's actually going to be significantly taller. It's still a nominal 16, but the actual dimension would be much deeper. It'd be maybe a full inch deeper or something like that. So you might be up to 17 inch or 17 and a half inch. I haven't looked it up, so I'm not sure. But you get the idea that that's how that nominal dimension works. So it's kind of useful if you can kind of keep that in your head. You have a pretty good idea of where those chunky bits are going to go. Eventually, once you start getting heavier and heavier, that web will start getting larger as well.